Okay, this is Mr. Musonda Alfred. Okay, welcome to this YouTube channel. Okay, remember to subscribe. It's very important to subscribe so that you can receive more videos. Okay, so now here we have got this question. This is our second question in this case. Okay, this is our second question. This is our question, which is lesson 2. Okay, on transformers. Okay, so now here we have got this question. It came in exams, that is 1999, paper 2 and question 12. It was like this, and some guys failed. Okay, so the preliminary information is that the transformer in the figure is connected to a 240 volt supply. Okay, so let's check the diagram. Have you seen? This is the diagram. We have got primary coil here, alternative current, which is very important in what? In transformer. Okay, then we have got 800 turns. Then we have got this is the soft iron core. It's very important in transformer. That's the one which is used. Okay, then this soft iron core. Then we have got this is the part for output voltage. Okay, then this is 40 turns. Here there are 40 turns. So you can see that here there are more turns, here there are fewer turns. Okay, so this is secondary coil. This is secondary coil. Okay, let's now do the first question. The first question says, why is soft iron a better material as a transformer core than steel? Why is soft iron a better material as a transformer core than steel? Okay, so now the answer is that this is because soft iron core produces or creates stronger magnetic fields. So because it creates stronger magnetic fields, which are used now in production of what? Which now these stronger magnetic fields now what enters into what? Coils in form of magnetic electrocurrent. Okay, so this is our answer. Now we come to the second one, B. Okay, B reads as follows: calculate the output voltage. So output voltage, now we write first our data. What do we have? Okay, we are looking for output voltage, the output voltage. Okay, that's the one we are looking for. So now in this case, let's check our data. So number 1, we have got number of turns in primary, and that is 800 turns. Then we have got now number of turns in secondary. Number of turns NS in secondary, it's 40 turns. Okay, 40 turns. Number of turns in secondary, it's 40 turns. Then from there we have got, when we go into we check here, we check thoroughly. We have got the transformer in the figure is connected to a 240 volt supply. Connected to 240 supply. So meaning that 240 was fed to a primary coil. So meaning that voltage in primary is equals to 240 volts. 240 volts. Then we are looking for voltage in secondary, which is output voltage. So output voltage, we say Vs is equals to question mark. Vs is equals to question mark. Let's now write now the formula. So we're going to say number of turns in primary over number of turns in secondary is equals to voltage in primary over voltage in secondary. Okay, at this point now we say, okay, let's substitute now. So number of turns in primary, it's what? It's 800 over number of turns in primary is 40. According to this data, it's 40. There's 800, there's 40 there. Okay, this is equals to number of turns in voltage in primary. Okay, voltage in primary, it's E, which is VP 240. So we write down there 240 over voltage in secondary. That's the one we are looking for. So write down voltage in secondary. At this point now, we are going to cross multiply. We do like that. Then we are going to have this situation. Now we are going to finish up this side. Okay. So we are going to say 800 times Vs. It will be 800 times Vs is equals to, then 200 is equals to 240 times 40. So I'm going to have this side 240 times what? Times 40. Okay, then we say 800 times Vs. 800 times Vs. We are going to have 800 Vs. This is equals to 240 times 40. Okay, so 240 times 40. Let's look for a paper. So we are going to do this. We say 240 times 40. Okay, you can see how we are going to calculate here. We say 0 times 0, 0. 0 times 4, 0. 0 times 2, 0. Here we put 0. Then we say 4 times 0, 0 again. 4 times 4, that is 16. Now we are going to write 6, we carry 1. Then we say 4 times 2, this is 8. 8 plus 1, 9. So here the answer becomes 9,600. So here this side it becomes 9,600. Okay, 9,600. Okay, this is how the answer becomes. Then at this point, or maybe the shortest method that we can do, we are just going to, because it is easy. It's always easy, like I always said, because I emphasize that always it's easy. Let's do this. So here I'm going to do this. Instead of taking too much time, we're just going to say 800 times Vs is equals to 240 times 240 times 40. So I'm going to say over. So in this case, let me copy this one. Just say 800 times Vs is equals to 240 times 40. So here now we are just going to say over 800. Over 800. Okay. So now in this case now, we are going to cancel 800 into 800. It's 1. 1 times the Vs, it will be Vs, which is voltage in secondary. This is equals to. Okay. This is what we have done. Okay. Then it's easy, I've told you. Okay. You can see. So this is 0 and 0 goes. Then 0 and 0 goes. That's why this formula is simple. So it just now 4 into 4, 1. 4 into 8, it's 2. 2 into 24, it is now 12. 2 into 24, it is 12. So this is now 12 volts. So in this case, the voltage, we have seen that in this question, the voltage have reduced. The voltage has reduced. So in this case, we have calculated 12 volts. So here, in this diagram, the voltage on primary was 240. So 240 has been reduced into 12 volts. So this means that voltage has been stepped down. So this is a step down transformer in this case. Okay, so now we go on to another item. Now, this item is question C now. As you can see, this question. Okay, let's now read this question. I read it as follows. Calculate the efficiency of the transformer if current passing in the primary coil is 4 amps and in secondary coil is 60 amps. So here, current in primary is 4 amps and therefore in secondary it is what? 60 amps. Okay, let's now calculate now the what? Let's now calculate in this case. Let's calculate the efficiency. Okay, so now we're going to say efficiency is equals to power output. So efficiency is equals to power output over power input. So efficiency is equals to power output over power input times 100%. So in this case, what I say is power. I just use the symbol P, power. Then this is output. So I just say P output over power input. This is P in. So this power entering into the device. Okay. So now efficiency now is equals to. In this case, do you know the power? Do you know the power first output? I think we don't know. So let's calculate for power output now. So I'm going to say power output, power out is equals to VI. So power output is equals to voltage times current. So in this case, this is equals to. So power out, the output voltage that we have calculated, in this case, it is 12. So we'll say 12 volts times the current we have given in secondary, it is 60. So times 60 times 60. So now power out is equals to, then we say 12 times 60. 12 times 60. Let's calculate here. We say 12. We start with 60 times 12. Then 2 times 0, 0. 2 times 6, that is what? 12. Like this. Then now say here we put 0. Then you say 1 times 0, 0. 1 times 6, 6. This is 0 to 720. So this is 720 watts. Because power is measured in watts. So 720 watts. So the answer here, power output is 12 volts, which is in secondary, which you have calculated, multiplied by 60, which is the secondary coil is 60 amps. Then the answer is 720 watts. Now, what's the power now in primary? So power in primary, let's calculate here. So the power in is equals to voltage times what? Current, which is VI, voltage times current. Okay, so now in this case, the power in is equals to voltage in primary. We have been given, it is what? It is this one, which is 240. So we are going to write this one, which is 240 times current in primary is 4 amps. So now I'm going to say 4, this is equals to 4 times 0, it's 0. Then 4 times 4, it's 16, we write 6, we carry 1. Then now we say 4 times 2, the answer is 8. 8 plus 1, it's 9. So this is 960 volts. So now we are going to come here and then we write down now. We say power output is 720 over power input is the one we have calculated here, which is 960. So we write down 960 times 100%. Okay. So now at this point now, we are going now to enter this into this. So in this case, let's try to cancel this 0. We cancel this 0 and we cancel this 0. Have you seen? Then at this point we say, we're going to say 2 into 10 into, we are going to say what? We're going to say 2 into 96. 2 into 96. We are going to have 2 into 9. We are going to have, that is 4. Remember 1. 2 into 16, 8. So here we are going to have 48. Then 2 into 10. It will be what? It will be 5. Have you seen here? Okay. From there again we say 2 into 40, 2 into 48. We are going to just have 2, then 4. We have 24. Then 2 into 7. We are going to have what? 3. Remember 1, 12 there. So 3 and this 12. Have you seen? Because this is now becomes 120. So it will be now 3 here 12. 2 into 12. It will be now what? It will be 6. Because if you write 3, now we write 1 here. 2 into 12, it will be 6. 2 into 0, 0. 360. So now, it is now, the situation now is 360 times 5 over 24. Okay. So now here now we're going to say, we are going to say 2 into 24. It is now 12. Okay. It is now reduced further. So there's a 2 into 36. It will be 3 into this one. 2 into 16, 8. Then we put 0 there. Okay. This is the way we do. Then we say now, okay, at this point now we're going to say 2 into 12. We have got 6. Then say now 2 into 18. This is 9. There it becomes 90. So now we are going to say, at this point we say 2 into 6. It will be 3. Then we say now 2 into 9. It will be 4.5. So in this case, in this case, we are going to say 3 into 6. It is going to be 2. 3 into 6 is going to be 2. Then you say 3 into 9, it is going to be 3. Okay, 3. So I've got 30 over 30 times 5 over 2. Then at this point now, we are going to say now that 5 times 0, the answer 5 times 0, the answer is 0. Then 5 times 3, the answer is 15. Then we say over 2. Then we say 2 into 15. The answer is 7. Then remember what? Remember 1. We add it to 10. So 2 into 10, the answer is 5. So you can see, finally, we have discovered that the efficiency is what? 75%. So therefore, we're going to say efficiency is equals to 75%. Okay, but if you have been using calculator, the procedure will be too simple. But because I'm not using a calculator, I just want to demonstrate without using what? A calculator. That's why the formula has been too large. You can see where I've passed through. This is the work that we have done. All these all this and then this, then we discover that efficiency is 75%. Okay, so we turn to the other side. We have got this question, which is question D. State two uses of transformers. State uses of transformers. What are the uses of transformers? Okay, so in this case, we have another question which says, explain why power at the source is transmitted at a high voltage. Okay, so for these two questions, can you please communicate so that I give you the answers in the comment box, in the comment section. So please request for answers on this, on D and E. See you in the next lesson.